Hello, I am Danny. I am um, glad to be here. I'll be talking about JavaScript and TypeScript. I do have laryngitis throat, so my voice is kind of going in and out. Don't worry, my throat doesn't hurt, so I feel fine. I'm happy. I love talking about all this, so you'll just have to bear with my Muppet voice that comes out every once in a while. So if uh, I promise it's not intentional. So please bear with that. Otherwise, I'm so excited to talk about today. So let's see. We're good. Okay. So who am I? I'm Danny Kirchmeier. You can reach me here, my email. You can find me on GitHub, and I'm currently a software engineer at School. I've been an engineer for 12 years now. Started off as an intern doing some product development work, and got to build some cool and exciting web apps using JavaScript and Java. We'll get a hint at some of those tools later. And now I get to do a lot of kind of back-end development, DevOps. If my grad, I keep servers online at School. About 30 engineers that we work with, and they all do things from the platform, which is like a remote learning kind of marketplace, allows teachers to teach classes, to sign up for classes, and I kind of help make sure a lot of the AWS stuff works, as well as making sure that there's no glaring holes and that people who don't need access to it don't have access to it, and vice versa. So that's a little bit about me. But we're talking about JavaScript and TypeScript today. So let's talk about that. So our goal today, not for you to actually learn enough to be able to write JavaScript and TypeScript. You can do that on your own time. What I do want to leave you with is a curiosity and a desire to go and answer some of the questions that you have and read up on it later and go through and try poking it with some of the examples that we'll look at and things like that. So if you're interested in this by this discussion, then that's totally okay too. Not going to be offended. So let's get started. Let's ask the question, what is JavaScript? Maybe you know, maybe you don't. To start off with how I'd explain it, like I'm 80 years old. So if my grandmother came up to said, "Oh, Danny boy, what's this JavaScript I heard about in the news last night?" I'd say, "Oh, it's the electricity in your house. It makes lights turn on when you push a button on a web page." And she's like, "Oh, okay, great, thanks." And she'd go about her day and go back to knitting, whatever she's knitting. And maybe my dad, maybe it would work. He thought of it like my dad, who's like 60, and he says, "Oh, this is JavaScript. Is this? I know somebody who does Java." And I say, "No, Dad, it's not Java. It's a different language." So if we are going to actually answer that, what I would like to do is actually go through the history of JavaScript. And I think that will help explain what it is today. So here, let me take you on a little journey of an unauthoritative history of JavaScript, mostly accurate with some slight embellishments. So the year is 1995, and you are a company named Netscape. You have a popular browser called Netscape Navigator, and the web development scene is flourishing, and people want a way to make more pages more dynamic. And so in September, you release a beta version of a scripting language in your browser. You call it LiveScript. And then in December, you have released it officially as Java, maybe as a marketing ploy to get people to think, "Oh, I know Java, I can learn JavaScript." It's entirely different. Any case, let's fast forward one more year, 1996, and now you are Microsoft. Seeing Netscape Navigator competing for market share with your own browser, you have Internet Explorer, and it's been out a little bit, and they own like 95% of the market share, but you're not willing to be beat that easily. So you decide to do what it takes to bring dynamic pages to your browser too. And so in August, you reverse engineer JavaScript, and you call your implementation JScript. And in 1997, you are Netscape again. You want your language to be seen as the standard. And you've been in talks with this standard organization called ECMA International. And so in June, You get the language form, but you end up compromising on the name, and it's called ECMAScript or ECMAScript. Same year, you are now a programmer. And you think that ECMAScript sounds like a skin disease. And so you and everyone else keep on calling the language JavaScript. Now, 1998, you're a programmer still. Even with the common standard, browser differences make supporting your multiple sites difficult. And then in August, the browser market share reaches 60-40, mostly Netscape, but Internet Explorer is plenty popular. So you take a shortcut in your website and you put a sticker in there that says this page is best viewed in Netscape, or 2000 rolls around and you are Microsoft. This is a new millennia, and IE is finally gaining market share, 75% market share, and it continues to grow. No signs of slowing down. You're in 2001, you are still Microsoft, and it's finally at 86% market share. IE6 comes around, and it's still trending upwards. And so you decide to take the back seat a little bit, and you decide to rest on your laurels and slow some new feature development. What was once aggressive, trying to come up with new ways to entice developers to use IE, you're happy with your market share, and you stop putting new effort into it. And so a few years go by here. In 2004 comes around. You're at this company named Google. You have some fancy search engine, and with existing but slow web-based email services. So you come up with some novel uses to some existing API that, well, it didn't sound that fancy, but it allows you to get new data from a server dynamically. And it allows you to make a new, very fast email system. And then you guess what this is called? Gmail. So Gmail, fun fact, even it was released on April 1st. And it was not an April Fool's joke. People thought it was. History of April Fool's jokes, but it was not an April Fool's. And they probably should have just waited a day to announce it. But anyway, they released it in April. Now the year is 2000. And now you're Mozilla. You're frustrated with the lack of progress made in web standards by Microsoft, and you decide to take matters into your own hands. And Firefox is released in November. 2005 rolls around. Programmer again. You've made a web page, and you found Firefox much easier to support than Internet Explorer, with its multiple tabs and even some of its developer tools and some of its extra insights that it'll give you. You really like it. And so in October, you start telling your friends about it. And by this time, Firefox has grown to 8% market share and continues to grow really quickly, all the way up to 30% within another year or two. Now, 2006 rolls, and now you're Google. Gmail is really popular, and it's really feature complex. Like, that code is becoming unwieldy. And man, trying to support all of the oddities of IE become a nightmare. You have some smart people on your team, but JavaScript developers, they're kind of in short supply. And the on your team, well, that you work with, they're all Java developers, and they hate JavaScript. And so in May, you release Google Web Toolkit, or GWT, or GWT. And it's a tool that actually compiles Java into JavaScript. Now 2008 rolls around, and Google, frustrated with IE and Firefox for being quirky and running JavaScript slowly, especially your Gmail, you decide to take matters into your own hands. How? You release the Chrome browser, a browser named for Chrome after like Chrome focused on speed and compliance to specifications. And this was a fast browser at the time. I mean, it was really amazing. People really fell in love with it. Now, in 2009, you're a guy named Ryan Dahl, and you're intrigued with the speed that JavaScript has been running in Chrome. And you're frustrated whenever you build websites. You've been using this Apache HTTP server, and it's just not performant. It's really not living up to the promise, and it takes up so many resources, and you end up having to spend tons of money on these extra servers, and you want something that's better. JavaScript stuff, and you think, I have it in my own hands. And so what do? You release NodeJS. It's a tool that runs server. That allows you to run a server in JavaScript. Now the year is 2009 still, and now you're the ECMA script committee. discrepancies between JavaScript implementations, these different browsers, and inconsistencies in your own specification, you decide to take matters into your own hands and modify version 5 of the ECMAScript. That's what's formerly known as ECMAScript 2009. Most people end up calling it ECMAScript 5, or really what's common is ES5. And this is a whole different like an addition of the language. So I wanted to point out that like in the language itself, like this adds new keywords, new tools that you can use. And so this is kind of like trying to make things easier and fix ports that they've seen come up over the years that people have been complaining about. So in 2010, you are a guy named Isaac Schluter, and you're impressed with Node.js, and you want to contribute to its popularity, and you want to find a way to help share code that can be used on this new. And so you release NPM, the Node Package Manager. A couple of years goes by, it's 2012, and now you're Microsoft. You're frustrated by the difficulty of developing large apps in JavaScript because you've seen the potential of the language, but you think it just needs more structure. And so you release TypeScript. It's a language that adds optional types and compile time validation on top of TypeScript. Then the year is still 2012, and you're Google, and you're pleased by the increase of JavaScript developers, and you're frustrated with GWT at this point. You're frustrated that it continues these words that have to support IE, how difficult it makes it. People who use GWT think that it's really just overkill and doesn't have the performance that they really thought they could. And there's new tools coming out in JavaScript land that they want to take advantage of that just can't integrate into GWT. And so you decide, we're not going to do this. We're going to reallocate some team members. And in June, you announce the transition of GWT to an open source project, and it quickly loses popularity. Now 2013 rolls around, and you're back to the ECMAScript committee, and you want to continue to improve language. So you study and you learn from some other languages out in this time. And in November, the final meeting of the year comes and it goes, and there's still disagreements on how to implement certain features. You're trying to do as big a sweeping change as there was between the previous versions, and ES5. Technically, it was only ES3 and ES5. ES4 was attempted but scrapped, but that's a whole different discussion. So ES6, they're trying to say, okay, this is going to be great, but man, agreements. And in 2014, you're a guy, you're Sebastian McKenzie, and you see these neat features that have been proposed, and even some of them that are accepted and going to become a part of the ES6 script, and you start using them now. And you realize, maybe I could find a way to write a tool that would compile that. So you actually build a tool, you call it 6to5, and that compiles ES6 code down into ES5 code, allowing you to maybe make use of some of these new syntaxes and new keywords now and not worry about what Node.js or your browser is actually supporting. And in 2015, you're still Sebastian McKenzie, and only been a few months, but 6to5 has become very popular. And you realize that all those ES6 features proposed, they're not always going to end up, and they're going to do future versions. And your tool is, well, it's becoming pretty powerful, and you want to make sure it's future-proofed. And so you take the name and you rename it to Babel. 2015 still, and you are the ECMAScript, and you want to continue to improve the language. And so you finally motion to just release the spec as is, leave some of the stuff that you've wanted to get in it out of it, and you establish a regular release cadence to protect against large changes and long delays in the future. And so in June, ES6 is released, and they don't want it being called ES6. So they say, call it ES 2015, because this is the 20, and we're going to be doing yearly releases after this. And now 2023, you're here watching this presentation. The committee has continued to release annual releases of ECMAScript standard. So you got ES 2015, 2016, 2017, 18, 19, 20, 21, and 22. And this year. And all the browsers, they now have multiple releases per year, and they incorporate standard features very quickly into their different engines. And Node.js, it even has annual releases and continues to be used successfully to power large websites. So let's go back to the started this whole journey through history. What is JavaScript? So we saw that it once was originally a language just for scripting the web, making pages slightly dynamic, and it grew to something you could build elaborate applications with, like we saw with Gmail. And while it was once originally was kind of like looked down on for being slow, it grew to become something that you can run at impressive speeds, like we saw with Chrome. And after that, we saw that it wasn't just for the front end, but it's become a back-end tool and tool-based language, so you can build anything you want, like we see with Node.js. We saw that people looked down on this once, but now it's actually become a language that people start to appreciate and kind of turn back to, like we saw with Gwt. And we saw that the language was once originally stagnant and not even well specified, and now it's become a regularly and well-documented language, like we see with ES 2015 and beyond. And what was once fully dynamic language without a compiler step, we see that it's grown to support tools that can now give you type safety and forward compatibility, like TypeScript and Babel. Let's talk a little bit more about some of those platforms and tools. We've talked a little bit about what JavaScript is, even though we don't really know the syntax. We've seen its evolution over the years and where it's led to now. So let's talk about that Node.js thing that came out in 2009. What is it? Well, it's a platform for running JavaScript outside of your browser. And it's only your regular JavaScript way to define and build arrays and build maps, but it also provides a set of APIs for interacting with non-browser things like files in your network and cryptography and other processes and anything else you can imagine that's on your computer that's outside of your browser. And in fact, there's even ways and tools now for interacting with. In order to do that, what you actually want is a tool called NPM. And we hinted at that a while ago, and it's a package manager. So it's a command line tool, and it uses Node. It runs on Node, and it uses and updates and allows you to publish shareable called packages. And so now you can install anything from a powerful server library like Express that allows you to write HTTP servers with ease. You can put in build tools like Babel. Even TypeScript is available and can be installed with NPM. You can install database libraries for interacting with your database like Postgres and you can add utility functions. Just make your coding just a little bit easier whenever you want to shuffle your array or make it specific item and a key, or maybe even kind of like take it down and remove all the duplicate items. And you can even distribute front-end platforms like React or Angular, if you've heard of those. So you can really do a lot. It's really a great way to share code. And so and what exactly was Babel? We saw a way to convert files using new or experimental JavaScript features and convert them into a file that uses only established features. So Babel actually supports a lot of plugins, and the way that it does this language definition stuff is actually all through plugins. And so you can even invent features of your own, and that's actually people will start with an experimental Babel plugin to try, and people will give feedback on before it's even taken to the ECMA script committee. So let's take a look at one of these. So here is this numeric separators. In some languages, you can do this thing where you put underscores in between numbers, just like commas or periods whenever you write a really long number, like 4 million. We see here, this is a lot more readable to see that the million rather than this one where you kind of have to look and count how many zeros there are. So we see that if we go back and trace through history, you can actually look in the presentation and click this link. This will take you to the first commit where an author created the numeric separators Babel plugin. And finally, it was actually adopted and made. Somebody didn't have to just go and install it on their own in May. So just 1 month later. And then finally, a few years later, it's finally been taken to the committee enough that it's actually adopted into what is now modern JavaScript as of a couple of years ago. TypeScript. Well, that's another build tool. You take language keywords and add types to your source code. And so using the TypeScript compiler, you can then validate that your code uses the correct passed around. And it supports some of those Babel proposals that are close to being accepted in future releases. So it can be similar to Babel, allowing you to use new patterns before they're fully available. So that maybe you don't even need Babel anymore because TypeScript supplies. Now, that's all well and good. We've talked a lot. I actually want to take us through some code examples. So before I do that, I want to make sure, does anybody have any questions that you are dying to ask before we actually take a look at what JavaScript looks like, maybe what one of these libraries looks like, how we use that, and also TypeScript? Got 3 sets of examples here. So do we have any questions?
If anyone has questions, you can unmute.
Yeah.
I think we can't actually raise hands here.
Yeah, so I have a question about TypeScript. Like in some projects, I usually see the TypeScript files and some JavaScript files. So is it? I know the process is kind of like you write in TypeScript and then it kind of transpires into JavaScript. How exactly does that work? And in practice, when you want to write a program, do you write it directly in TypeScript or you write in JavaScript?
That's
Which
a
one is
great question.
Yeah.
Yeah, that's a great question. So I didn't really say this there, but technically TypeScript is a typed superset of Java, which means that everything that's valid JavaScript is valid. Everything that, and then you take that JavaScript and you just add types to it. And so you can do that on a per file basis. You can do that across a whole project. So maybe you really have one section of your code that's really gnarly, and you don't really want to make all of your code TypeScript. Maybe you just want to focus on complicated. And so maybe you could tell TypeScript, just compile this one file, and it can even use JavaScript files and just kind of accept that it doesn't know anything about them, and that it's leaving you. It's just kind of say, I'm trusting whatever you write here because I don't know anything about this. So you can write really large projects in TypeScript, or you could just piecemeal them together. Personally, I write everything I can in TypeScript and try to make aggressive use of types, because then it's providing not just documentation to say, hey, this is what's going to happen as well. And let me tell you, I make lots of mistakes as I'm typing out stuff. In fact, in these examples that we'll get to, they're on JavaScript because I wanted to not show off TypeScript in some of them. And I made so many mistakes with them. I was almost tempted to write it in TypeScript first and then just remove all the types because I was having such difficulty with just trying to use JavaScript or without TypeScript, because I'm so used to the TypeScript in the IDE tools telling me what is valid and giving me very quick feedback about what I'm doing right and wrong.
Awesome. I also have a question, and well, I guess it's more of a it's kind of related to this. What language was JavaScript originally written in?
So the implementation, I do not know. Mosaic was, or whatever Netscape Navigator was running at the time, it's probably a C-based language. I know that it was heavily inspired by Scheme, which is a very dynamic language. And at that time, it was popular enough to use languages. I'm not sure if Lua existed yet, but Lisp was popular at the time among people who were really hardcore into programming. And so it's very possible that they would have embedded a runtime that used that did some very dynamic processing as a separate kind of process from Netscape Navigator. Nowadays, the JavaScript implementation, the primary one is Chrome's V8 engine, and it's written in C.
Okay, cool. Do we have any other questions right now? Okay.
Well then, let's take a look at this example. So we're going to be on a site. This is called glitch.com. Glitch.com provides a, oh gosh, my voice is, it's getting worse. Anyway, I feel going. So glitch.com is a site that provides a free runtime for you to build front-end and back-end projects in Node. You can pay for it if you want some of their like faster stuff, but I build lots of really just simple tutorials, examples using this. It's a great way you can contribute with friends, and it's live updated. So this is actually dtgm-http-basic.glitch.me. You can go to this in your own browser, and you can see this. In fact, if I make changes here, you'll actually see them come up. Now, I've already built this. You could try this, and we'll see that we'll actually be typing in some input here, and it will be running. But I kind of want to walk you through what this looks like. So here in this project, we've got a couple of files. We've got a get ignore file because it's uses Git under the hood, and a license file that just says you can use this however you want. We're using Node. Node you say what you depend on with a package. And we're not using it. We're going to use just and all of its built-in tools. Some models that Node didn't have back at the time, but very similar code to what would have existed back in 2009. This server is serving out. We'll take a look at that real quick because there's nothing about this. Very simple form. Got a hello world header. Here we are using some to kind of find these elements and go too much. Maybe I'll go through it later. Here we go.
Oh. Can everyone still hear the presenter? I think he has some internet issues.
Hello, everyone. I think he'll be back with us shortly.
That's strange.
Here we go. Can you?
Yes, we can hear you.
I am. I don't have the best internet here, so I'm going to keep my video off just to save a little bit of bandwidth while I share screen.
Sure.
Okay. So let's see. So NodeJS will read this entire file and JavaScript evaluator walk through and recognize some syntax and kind of pull out certain things and then start executing the code top to bottom. So let me point out that functions can be used before they're defined. So in this case, I'm actually using this function before it's actually before the line of code that it is written in exists. This is called function hoisting. This is a feature of JavaScript. Some languages like Python don't allow this. Some languages like this one do. So in any case, Java, these functions exist, and that it'll kind of allow you to use them even though it hasn't gotten there. So really, what will happen when we read this file is it's going to execute several lines of code. First off, it's going to read this line, and this line tells us that we want to make sure that we are using the latest, kind of strictest form of JavaScript. If you remember, there's a version of JavaScript that exists prior to ES5. And in ES5, they added this special string at the top of a file that if you put this string as the first line of the file, it disables the use of some really weird features that existed in ES3 that you really shouldn't use. So really, all modern JavaScript files should have this in there. And in fact, there's certain modes to where you don't have to put this in there and it's automatically assumed. Now, the next thing is actually a NodeJS function. And this one is a special way to get access to other libraries, or in this case, a node built in. So we're using some of the node APIs here for interacting with HTTP, for interacting with file systems, and for interacting. So in this case, I've required the entire library. And in this case, I'm requiring one little function out of this library. And I'll get into what those look like here in a minute. But we can see that right now, as soon as the program starts, I've pulled in some libraries. I'm creating a server. This create server takes a function that says, here's how you handle a request that comes in. And again, or is my microphone stopped? Okay.
Yeah, we can hear you.
Okay, great. And then as soon as we've created the server, you can listen you can tell it to listen on a specific port, which is where the server will actually come online. You pass in a callback so that you actually know when the server is available. So yes, this is very similar to importing libraries in Python. Now, I want to point out, so was created. The purpose of this is to take JavaScript and allow it to be run on the back end and not do blocking operations. You want to use the real thing that appealed to Ryan Dahl, the inventor, was non-blocking IO. So think of it this way. I can do one thing at a time, right? Like you could kind of, if my child came to me and asked me to do something, I could go and make them the peanut butter and jelly sandwich that they asked for. And while I can't actually be working, I might be able to think about something in my head, but I'm actually not going to be able to actually get over there and start churning out code while I'm churning out a peanut butter and jelly sandwich. So I'm kind of single-tasked, single-threaded, single-minded. And JavaScript is very similar. It can do one thing at a time. But it turns out that a lot of what computers do is, well, wait for things to happen. Like we think, like as fast as the internet is now, the fact that I can see your video across the world, the fact that you can hear my voice, like this is still monumentally slow how fast computers actually are, with how fast, they can compute, they can count to 3 billion in the matter of a second. It can go really fast. So what Node does is it takes advantage of that. And so it actually puts things off that are happening asynchronously. And hey, start up this server, because when you start up a server, it actually goes and kind of does some things in the computer on the side. And that stuff actually takes like half of a millisecond or half of a second to actually start up and come online, or maybe it takes a few milliseconds. In any case, the computer can do a lot more during that process. And so everything about Node is built around asynchronous handling and waiting for things to happen. So it goes and executes all this code synchronously, but then whenever it actually starts up the server, you don't know that the server's done until this function right here is called. And this is a way without the function keyword, just using a arrow bracket and curly brackets. So here we see that the server is online function log will be called after this. And so that's how we know to do that the server's online and we can do other things. In this case, I'm just logging, but if I was doing more elaborate software, I might also initialize a database connection and wait for that to come online before maybe really saying that my server is okay and things like that. So now that we've created a server and we're listening, let's walk through what it looks like to actually handle an HTTP request. And this is very low level. So the Node API, they want to give you the freedom to do anything you want, but the best way to do it, they give you lots of tools, but they want you to actually figure out the best way to use those tools. Here, you create an HTTP, you handle an HTTP request, and every single request that comes in goes to this function. Now, we have two routes on our server. We have the base route that you go to whenever you load the server, and you also have the API reverse call, which is used here, so that whenever we type in something like noon, see that it gets properly reversed into, oh, well, maybe I should, something like Taco Cat. So we see that it actually gets reversed. So here we see that we have several requests coming. We're handling this request and we're passing these objects that we have. So we have a request object that comes in that tells us details about what came in. And we have a response object that we send data back. And so if we went to a bad URL, like, foo here, we would get back this not found response. And the server would tell the browser, hey, this is a plain text response. Don't try to, render and see if I'd use a monospace font, and use a status code of 404, which is just a way to tell other monitoring software that it wasn't found. But if we go back to the basic, we'll see that we've got our basic form going on here. Whenever we load that, it handles the index request. And whenever we do the API reverse, it handles a reverse request. So we've seen kind of a basic use of the library. Here, we create a server and it tells us in the documentation how to actually handle requests. And so I do it this way. And I also want to serve up a file because I have my public index.html file. So let's take a look at how that works. And so here we're going to tell the browser, hey, this is an HTML content type that's coming back to you, so that then it will actually render as HTML. If we were to change this, for instance, and so, hey, actually this is text plain, and then we refresh this, notice that now it doesn't even try to render it. It literally prints out the source code because we told the browser, hey, this is no longer HTML, but plain. So this is how to do that. Another feature of Glitch while I'm here is auto reloading of this preview. So as you work with Glitch, if you ever use this in your own projects, you'll get to see of your server or your pages as you make changes. Really fun feature, especially for doing short demos like this or building a cool site. And then after this, we set up a pipe. And this is a relatively newer function. This allows you to take a read stream and send it to the response. And then if an error happens, well, log an error. So Node is built around asynchronous operations. And operations need to happen quickly. And we don't want the computer to do too much all at once because there's tons of things that's multitasking. It's not really multitasking, it's just jumping between them so fast that it feels like multitasking. What we want is we don't want to read the entire file all at once and wait for that file to come back and then give that file to the browser. What if this file was huge? What if it was, a 4 megabyte index.html file with tons of ads and tons of JavaScript and tons of CSS? We wouldn't want that. We want it to be fast. And so you create a read stream. And so what this does is this really quickly opens up the file and allows you to pump data from out to the server in a very efficient manner. So if we were to look at the memory usage of it, would be very, very low. Even if you so megabytes of HTML to serve, the memory usage would be very, very minimal because it's only reading small chunks and sending it out to the browser immediately. Now, there's some caveats to this in that there's some error handling that I'm kind of missing. Even though I have this error handler, there's some other ways that the error could fail. Maybe the browser walked away. There's a lot of things that could actually go wrong and crash our server. So do be careful if you do try to the low level. And we'll get to what a library, and we'll see how much easier that is here in a minute. But before, I want to take a look at this reverse request now. So this is our second example. And we see that in the front end, if we were to look at the code, that it does a post, and it sends this input here in some JSON payload. So here, if we take a look at the body, or we take a look at this function, we see that it sets up several event handlers. This is how it knows to respond to the request. So the request comes in, and remember, Node is all about streaming data. Even the request data comes in a stream in little chunks. And so we have to put those chunks together into an array. And whenever the request is finally over and we get all of it, then we in a buffer. Now, in this case, we're trying to get the entire content of the body all at once. But what we're actually receiving a file and we want to save that file, then I would receive that entire thing. I could actually just write it straight to the file. There's also a corresponding create write stream that I could write to my file system. And so, this would be a good place where I would actually not want to just chunk all of my data into an array. And that's why Node.js gives you flexibility. But at the end, it becomes a pain whenever you write something simple like this, where you want to get every one kind of chunk of data. And so we have to take all these data chunks. And they're not strings, they're buffers, because they could potentially carry weird characters in them, especially if we were getting a file, and especially if that file wasn't a text file. Like what if we were getting some Word document file? Have you ever tried looking at one of those? It's just gobbledygook inside. So if we get some raw data, well, we know in this case, and so we parse it into JSON data, which is just an object, and then we can get the input out of here. And then we can split that onto each character, reverse it, and then join it all back into one string. And then here, we'll finally say, hey, we're sending back some JSON content, and we're going to that payload with this reversed as this reversed object. This is called object restructure, by the way, where you build an object. So this is very similar to reversed, but because I have the same variable name here and here, there's a shortcut you can use in modern JavaScript called object restructuring, where you build an object like this. Makes it very little things, or for debug logs too. And so that's actually what's going on right here. We're using an inverse right there and right there property of this. So instead of saying, .url, we're actually saying, hey, pull this URL out of the request. And if I was going to use some other things, maybe like some HTTP header, I could pull those out as well. I'm not, so we'll just pull out the URL. I mean, we'll just pull out the pipeline. This example of a server in Node, pretty complicated. Had to take a lot of things from the standard library to kind of put together. And some of these functions didn't even exist. This used to be even harder before the pipeline existed, for instance. Now, the HTTP server and file system stuff, this is you just have to call a few more APIs if you didn't want pipeline. But pipeline's really nice. And this actually started off as a Node, as a package in npm, excuse me, that eventually got adopted into Node. But that's a brief aside. Let's take a look at another example. So in this case, this is another one. Very similar URL, very similar project. This one is, instead of basic, Express. We're going to be using a library, an HTTP library called Express. And Express is a relatively unopinionated library that allows you to do a lot of powerful stuff in a lot shorter ways. So here we have the exact same index HTML file, aside from saying a slightly different header. And here's the exact same code. So in this case, we require express. Now notice the lack of a node colon prefix. That node isn't technically required, by the way. There is a way you can just say HTTP, like it does look nice to use the node. And if you don't use the node prefix, you might run into a collision, because what you do for saying you want to use a package is in a package JSON file, you say you have a dependency. You say you have an express dependency. And so here we see we're using version 4.18.2 of Express, and npm, after you run npm install, it will install this into a directory that we can't see here, but we could see on your machine if you were to run this. It would be node modules, and it would store all the code needed that Express builds. And then all we have to do to use it is say require Express. And now we have the Express library. And the Express library in this documentation says, okay, well, you start off by calling this as a function, and it gives you an app. And then you start using some of these special middleware functions. And this function is a special way to automatically parse JSON and store them in the body, which means that whole buffer bit that we were having to like do the concatenation and then put it together and then do the JSON parse, this handles it for you if you tell it, if your requester tells it to. And we do, so we can take advantage of that. And here, well, now we don't have to have some handler, some generic handler that handles every single request that comes in. Now we can use some nice functions that say, hey, when somebody does a get to this URL, send back this. And look at that. Express in its request and response even has a function called send file, which allows you to directly send the file back. And it takes care of all of the error handling for you. This is a really nice function for doing some of this kind of stuff. And in fact, there's even a way in Express to say, hey, I want to serve up every file in a directory. I didn't want to show that off here because I wanted to make it very similar to the other example, but that's just the Express static server built into Express. And here we can say something similar. We can do a post request. We can say, hey, whenever you do a post to API reverse, here's how you handle that. And so that will call this function. And then look at we can just pull it straight out of here thanks to our JSON middleware. We get the input out of this. And then we split it, we reverse, and we join it. And look, there's even a res.json, which makes sure that you send back the proper JSON header type. And in fact, this send file, it knows that you're sending HTML. So it's going to tell the browser, hey, this is an HTML file. Look at all of this that the Express library. And then a very similar way, it'll say, listen, whenever you want to tell the server to actually start, you give it a port, and then you know via the callback function when it's actually executed. And so we can see here that this, well, it runs very, very similar. We'll pump this in, and it reverses it just like we would expect. And so we can see here the advantage of using these libraries. And NPM has a ton of libraries. I mean, if you go to the NPM.js site and we look, they used to have a stat of how many libraries they had, but you can find anything. I mean, let's build, let's actually wanted to, I don't know, connect to a data. Maybe even have an ORM to have a fancy database for MySQL. So that then you're not just having to write raw SQL requests, but you can find all sorts of packages. Some of them are popular. Some of them have lots of versions. Some of them really haven't existed for a while. All sorts of different people trying out different things. Some of them, like this one, says it supports TypeScript and supports all these different types of servers. You can find packages just about for anything, very similar to Python and pip, but yeah, in a very similar way, if you're familiar with that. Having a package manager, and this is just like that. But no, the NPM one is one of the largest ones I've seen. And you can find just about. And the nice thing is it just gets installed in your local directory, and you have access to that source because it's all JavaScript, and you can look at that source. You can figure out, you can find if there's bugs. For instance, at my work, I recently found a bug that required me to go looking through some of the source code to find out that we had a memory leak where somebody was storing and holding on to data that they didn't need to hold on to anymore. Crash, and I was able to debug that because I was able to look for these. JavaScript is, well, almost always readable, and whenever it's not, you can put it through fancy prettiers online that will make it even more readable and help you. So we've kind of talked about what a server looked like in JavaScript, what a server looks like in Express, and now I want to go over to TypeScript. So for this, I'm going to take us over to the TypeScript playground. There are some tools that integrate with TypeScript and do similar things to Glitch. Glitch doesn't do TypeScript in their editor. One of the things that I like about TypeScript is the feedback that you get here. So in the example that I have in the spreadsheet, or the slides, I've kind of gotten this full fleshed out for us. But what I want to build is, well, what TypeScript would look like if we were to specify and build that reversal function. So let's do this here. So write live, we'll just say, you know what, let's define a type. And so in TypeScript, you can say, hey, I have a type, and this is going to be a request body. And a request body looks like an object that has a property on it called input. And that input property, well, it's a string. And here it is. Now we know that if we use request body as a type, we have an object that has an input property, and it takes in a string. And let's go and type out the response. That response body would look like something similar. You'd have a reversed, and it's also a string. And so here we are. The very basics of TypeScript give you just some type definition. Now, over here on the right, this is actually going to start emitting JavaScript. And right now, there's no JavaScript because we haven't written anything that actually gets persisted into JavaScript land. These types are gone. So the TypeScript compiler completely removes them. But if we were to do something like a console log and say, hello world, you'll see that that actually shows up over there because, like I said, JavaScript is valid TypeScript. And we don't do anything in this case that is we're not using types in any way other than knowing that there's a log function console object. So there isn't, for instance, a log that exists. And look at that. It's actually underlining it and saying that log doesn't exist on console. And it's giving us an error over here. Now, it's still emitting that JavaScript just in case you actually wanted it that way. And there's actually ways you can tell TypeScript in its configuration files. If you were to go and look at tsconfig option, you can find all the ways you can configure TypeScript. We're not going to go into that because that's a really deep and really deep concept and talk to go into. But suffice it to say, we want to know that we are calling the right function, so we can see log. And the nice thing about TypeScript is in this case, we can actually ask the editor to tell us what all can we do with the console, which is really helpful whenever you are working and saying, well, I'm trying to use this and I don't exactly remember how do I do a group? Oh, hey, there it is, group. And oh, there's a group in function. I bet if I was going to do a group, I would need to do something like this, start it and maybe end it. And that would give you a way to start. Here we are, we're going to define a function. And in JavaScript and in TypeScript, you define a function with a function keyword, and we're going to call it reversal. And here we go. We've got a reversal function, takes in no parameters, does nothing, returns nothing. Now, in TypeScript, you could actually leave off the types depending on your configuration. I don't like to do that. I like to fly strict and ask the TypeScript compiler I've done wrong. So in here, I'm going to tell it, I want to take a body and body, a type, and it's going to be a request body. In TypeScript, you specify types after the definition of parameters and variables. But over here, we see the JavaScript, it's just a body. So over in JavaScript, we wouldn't have any types. Now, we also have a return type that we're going to want, we're going to want to make sure we get a response body out of this. So we give, just after the function definition, before we actually get to the code, we want to say, hey, return a response body. But TypeScript compiler telling me an error. Hey, what's wrong? A function whose declared type is neither void nor any must return a value. And so we see already TypeScript is guiding me down the code I need to write. Hey, you're not returning anything. You've got a problem. So, okay, I'm gonna return a string. No, in fact, here it is saying type string is not assignable to type response body. Handy TypeScript typer thing telling me that I've got a bug here. That's great. Love it. So let's go ahead and, you know what, let's build this. So we're going to start off here. We're going to take that input and we're going to split it into different characters. Now, TypeScript compiler, what are you telling me? Once again, input, you can't find input. Oh, hey, that's right, because I need to actually say body.input. And now we split it, and that split function, it's telling me what the split function, some of the parameters it takes. And it's also telling me that it returns a string array. That string, square bracket, is an array of individual strings. And that's still not a response body. So of course, we've got to take that and we've got to reverse it. And then we're going to join it with like this. And we're going to store that in our variable. And then right here, we'll return reversed. And now TypeScript is nice and happy. And it even recognizes the syntax of that object restructuring. And it would recognize it either case, whether we have the restructuring or not. Now, let's say we know that the output type is reversed. And so we've got this going on right here. TypeScript will detect typos for us. So if we had this reversed right here, typed properly, and let's say we had another typo right there, look at that. Reverse said is not assignable to response body. Reverse said doesn't exist in type response body. And it even tells us, hey, did you mean reversed? It's really handy. I have made so many typos in my time of writing JavaScript. And I made so many typos just writing this 23 and 46 lines of JavaScript and under 100 lines of code. I had to go back and fix like typos that TypeScript alone would have told me was wrong before I even ran my code. So TypeScript saves me a lot of time. But of course, it can't catch every bug. Like, it doesn't know the difference between trying to split on the new line character in this. So it doesn't know that I've implemented reversal wrong. So I can still make bugs, but I've at least used all of my functions properly. And I'm using the typo, split into splits, or things like that. Or I didn't accidentally use some function like split that actually returns something entirely different and takes in not strings, but numbers. So there's really I find a lot of value in large code bases from TypeScript because they tell me what I'm taking in. They provide limits for me and help guide me to write better code and avoid a lot of silly mistakes from silly typos. And the editor experience, especially in a good IDE like this TypeScript Playground or in an IDE like VS Code or WebStorm, you can really get a lot of feedback before you've even run your code, which can save you valuable debugging time and also highlight potential problems that you might be running into. And so with that, that's the end of my talk. That's everything I had that I wanted to cover. I hope that at this point you are kind of curious about what TypeScript can look like, how you can write more of it. Maybe you could go around and play with these in Glitch. What you can do is you can remix a project. You click a remix project like this. So if you find this project over here, and there are slides that I shared, you can go and look at these and you can remix them and change them and run them yourself. It's free. You can run something. It'll stay up for 5 minutes and then it'll come up as soon as you need it. There's a little bit of a delay, but you're getting something for free. So it's really nice that they provide this value to you. So you could try either the Node Basic one, maybe go see if there's a different library. There's other examples too. In Glitch, you can go and find other things to remix that other people have made. You can go and find a different server. There's one called Fastify that's even more feature rich and can let you do templates and other very nice injections of different features. But that one was just a little too complex for what I wanted to highlight today. So I didn't dig into it yet. But there is a lot you can learn and dig into in JavaScript and TypeScript. And I don't know about you, but I've been writing JavaScript for a while. And the JavaScript that I grew up writing looks completely different and had a lot more bugs in it than the JavaScript that I write now, not just because I have more experience, but really because the language has improved in giving you better tools and language and keywords to help prevent against silly mistakes, and giving you more functions, like even this reverse and split function. They didn't exist in JavaScript in 2001. So the fact that we have things now that are still getting added to the language is something that I find really exciting. But that's enough of me. I will come back to the last slide that I have here, which is just a thank you for listening. You can find me and email me if you have any questions or want to talk some more. You can find me here, find me on GitHub. I don't do Twitter. Yeah, so just email for me. But otherwise, that's it.
Cool. Does anyone have any questions? I think we've talked about a lot of stuff there. Some of you might have some questions. Well, I have some questions. So going back to asynchronous programming, because of the way that whole thing works, does that mean that you don't always know the order in which your code will get executed?
Yes, that is absolutely correct. In fact, that's such a great example. I'm just going to pull up my code. We're going to do this right here. Pull up a terminal, get that ready, and then I'll share my screen, and we'll dig into what that would actually look like. I wasn't prepared to go down this route. Probably should have been, but so let me just start off here. We're going to do this, starting up a little editor and bringing this up. Okay, here we are. We are ready to share screen and coming back. Okay, here I am. So I'm using a called Fleet. This is an experimental editor that I kind of like. So just it's got syntax highlighting and a little bit more, but it starts up really quickly. I didn't want to try and use the full IDE. We'd be here for a minute before it actually would start up. Let's start off with a simple little JavaScript file. We'll touch a async example, call it JS, and over here we'll do this. I'm going to go ahead and turn on smart mode so it gives me some nice features. And in here, I'm going to start off this with a console or const or a console log. Hello world. If we run this like this, so node, you just execute it with the node command line. We say hello world. You could do this in some other places online too. This is the place that I have readily most available to actually run some of these kind of console logs. So let's set a timeout. So we'll do this. So this will execute our handler, which will just do console log executed later. And we'll say that it executes, oh, here we go. It takes a handler and takes a timeout number. And this is going to get executed, let's say 500 milliseconds later. So if we do this, now we run node async example, hello world, and then executed later. Executed later. So we can see that it does this. And remember, you asked, is this execute, do we know what order this is executed in? And well, we kind of do, but we get this stuff that comes later. Hello again. If we run this, you code and say, oh, I'm going to see hello world, then execute, and then hello again. But what you'll actually see is hello world, hello again, half a second later, executed later. And that's because JavaScript is going through one line at, and it's saying, oh, hey, I'm going to run this in half a second, save that function for later, go ahead, keep on running until I run out of things to execute. And then wait until this other thing in the background comes through and finally executes well later. Now, we could then know that this is going to run. And so, if you had some function that was depending on this, well, you might, call that other function later or something like that. And if we do two of these set times, and, we put in some identical time, executed later 1, executed later 2, we should see 1 and then 2 happen pretty much every time. Trying to keep those functions in order that they've been kind of scheduled. But it's not 100% guaranteed. Some things could go on inside of Node that would actually not get executed exactly in that order. Now, if that was important to you, there are ways to handle that. And so one of the key words that you see in modern JavaScript is something called async. So in fact, in that example, in that HTML code, if you were to go and look at it, you'll see that I actually write an async function. And in here, we'll actually have access to awaiting for things to happen. And so let's call this main, and we'll execute main like this. And we're just going to go ahead and take this code, and we'll pop it all in here. And so we run this, and well, nothing's changed because we're not really making use of this asynchronous behavior. But in here, we actually have access to a keyword called await. And so we're going to await. And what you await is a promise that eventually gets fulfilled. Now, this promise takes a function, and it takes parameters, a resolve, and a reject. Now, in this case, we're going to set a timeout. We're going to set a timeout. We're going to say execute later, and then we're going to resolve. And we're going to resolve, well, with nothing, because that doesn't really matter at this point. And we're not rejecting because nothing went wrong. So here, in this case, what we will see is hello world, half a second later, execute later 1. And then, because we don't use async here, it's going to say hello again, and then 500 milliseconds later, come and say executed later 2. So let's see that. Hello world, execute later 1, hello again, execute later 2. And so if we wanted to, we could even come back and say, hey, you know what? Let's come and make this in here like that. And now you'll see it in order right there. Boom, 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 boom. And in fact, you might even say, wow, that's still really complicated. What if there was something better? And in fact, in many libraries, there's an async function that you can import. Async function sleep. And do you know how that function is defined? Well, just like this. It takes in a number of milliseconds, and then it does a return, new, promise, resolve, reject, or just resolve. And inside here, it's going to set timeout and then call resolve, just like that, after so many millis. And in fact, because this function can be put in right here, you'll even see it look like this, where you just pass the resolve function directly into set timeout, having even less stuff you have to worry about. Now, this editor is helpfully telling me that millis here, and I called this mills, so I'm going to fix that. And it's also telling me that I haven't used my sleep function. So let's go take a look at this now. We could say await sleep 500, executed later 1, await sleep another 500 milliseconds, and There we go. And now this code looks, well, very streamlined and ordered. Boom, boom, boom. But
Cool.
under the hood, JavaScript is actually stopping and not doing anything during this time. It's like it's literally going to sleep and saying, hey, I'll set this timeout and I'll resolve later. And this async function is returning a promise. It's returning this promise. And that comes. Now we could even store this if we were, maybe we wanted to resolve a value. Maybe we actually wanted to resolve, I'm done. You could actually get that value right here. And then whenever you log it, we could actually log that value. And we can see that I'm done value is actually coming out of this, getting resolved, getting returned out of this. And so now you can build a function that maybe did a database query. It goes, talks to the database, and it comes back, well, this is done. And you can wait for it. And you can build this asynchronous thing that is separate from a different asynchronous function, because all under the hood, it looks like it's synchronous. It looks like it's going in order, and your code is, but it's actually waiting. And that allows you to build very streamlined stuff.
Well, that's cool to know. So we can basically write these async functions to different files, and then we can sort of import them, and our code seems to make more sense. Cool.
Yeah.
Um,
While I wait for other questions, because nobody's put one in the chat and raised, we could even move it to a different file. So we could say, hey, let's create a sleep.js. That's where my sleep function is going to go. And over here, I'm going to bring this in. Now, we saw the require keyword, and we're using some plain JavaScript right here. But what I want to do is actually change it. So we're not using sleep.js, we're using sleep.mjs. So part of new JavaScript is called supporting ES modules. It's this syntax that allows you to share code in a standard way than what Node came up with. Node is great, came up with this require and way of sharing code, but that's not standard. And only Node really does that. A new standard is called modules. And so what we're going to do is we're going to take use of that. And we're going to export that right here. We're going to export this async sleep function. And then over here, well, this function needs to be an MJS file too. So an async example is going to be async example MJS. So we just renamed it, changed the suffix, and it looks very similar. But now, instead of having to do a require statement and figure out what that would look like, we'll actually say import, and we're going to import sleep from sleep.mjs. And so here we are actually building out different files and saying, hey, this is the sleep function I want to use. And now I can do this. And now one nice thing about MJS files is that they allow you to use await at the top level. And so now we don't even need that main function anymore. We can literally write our script like where we write some console logs, await here, and node, a example in JS runs just like we thought it would. Sleep is now in a different file, which allows you to organize your code better.
Nice. Okay. Does anyone have questions?
Yes, Ife, that is yes. So the Node.js standard is called CommonJS, and that uses the require keyword that we saw earlier. And yes, the new one is called ESM modules. There's a few others that existed in this time. We could go into a whole stuff. In fact, that whole history thing could be like turned into a college class where you like dig through all these different like details in JavaScript history. But to see the language evolution as a whole, I think that was probably enough to go into. So yes, we're looking at ESM modules here because it's I find it really exciting. So if nobody else has any questions, I could walk through converting this to TypeScript. I don't really know what the time cutoff is. I can keep on going for hours. I love doing this kind of stuff. So Joshua, if you want to cut me off whenever or let me know what time I should end, please let me know. Otherwise, I will keep on going and just keep on talking and coming up with examples to share.
Yeah, okay, let's see. We have 13 more minutes for the talk. So do you think you're going to be quick with the TypeScript part?
Oh, yeah. I've done this plenty of times.
Okay.
So now we'll get to see an example in here. We're going to add, we're going to install TypeScript. And TypeScript is installed as a NPM dependency. So the easiest way to do that is to say npm install TypeScript. NPM nowadays, thankfully, takes care of JSON file and automatically manages your package JSON file for you too. So here we installed TypeScript, and you'll see a few things popped up over here. There's a modules directory where we can go and look at the source of TypeScript. There's a package.lock, which tells us the exact version of TypeScript we're using. And there's a package JSON, which says we have a dependency on the TypeScript package right here, 4.9.5 or anything newer. But package.lock says exactly 4.595. So that keeps us in sync with other people. Here we are. We've got TypeScript installed. And so now we want to start our TypeScript project. So now the TypeScript compiler is called TSC, and that's not immediately available on my machine because I installed it with Node, and my terminal doesn't actually know how to find the I installed because that's not on my path. So what I need to do is actually call that. And so I would say npm run TSC for me. Or maybe it's exec. I can't remember that. Yeah, exec. So here I am running the TypeScript TypeScript command line using npm. So npm knows that I have TypeScript installed. And in fact, if you module directory where it has all of these executables for us. So we're looking at the TSC command line. And right here it says that there are several things like initializing a project. So we need to do that so we can make sure that that gets set up right. So we're going to say exec init. So that's going to create, excuse me, what, hold on one second. There we go. The npm executor. It's been a while since I used this. I use a few other tools in my day-to-day job. Requires to kind of make sure all the extra arguments go to TSC and not to npm. So TSC init starts up the TypeScript compiler. And now we have a tsconfig. There's tons of compiler options. But at short, we are saying, hey, we want to target the ES 2016 spec. We're going to be newer than that. So we're actually going to do 2022 or 2021, because that's the version of Node that I'm running right now, is one that has that. I'm going to want not CommonJS ones, but Node 16 modules, which that's the version that this in Node. Things like strict and a whole lot of compiler options. We're not going to get into those, but we now move that file into a sleep TS. So that's all we have to do is change it to MTS. And now it's, and same thing with that async example. Move async example MTS. And here. Now, let's see if TypeScript is. So we're going to run the TypeScript compiler again, and the TypeScript compiler has a handy watch flag. So I'll give it -w and start watching my code for any errors. And in fact, there is one error because it's valid TypeScript, but it's missing a type. And with our strict configuration, we actually need type to make sure that we are typing our code properly. And so here it says has an any type. Now in TypeScript, there's lots of types you can say, but any is the least powerful, most generic one. It says take in anything. I don't care what you work with. I'm going to take it in. And so that's what we're going to do here. We could say any, but actually we know something better. We know that. So now we've said it's a number, and the TypeScript compiler went on, and look at that. We've files back in our content, and we can see this is what TypeScript generated. And because our target is modern JavaScript, it works very, very, it looks very, very similar to what we had been writing. So if I went back and said, actually, I want something a little less modern, maybe ES5. Does that work? Oof. There's now. And in fact, it says, let's see, what are the errors here? If we do this, it's going to say, hey, the await expression, it's only allowed newer targets like ES 2017. So we're actually too old because await didn't exist back then. So TypeScript is saying, hey, I can't actually down compile down to that version. So we'll have to go to maybe 2017 and let's see if anything changed in our JavaScript. And nope, it looks very similar. And this is because we're using that really special, but we can already see what it looks like. And so now we can run that async example MJS file, and Node runs with it. It works. You can even come back, make a few changes, add some extra parameters in here, and it just keeps on running.
Nice. Awesome. Okay, I think we're at the end of the session, but cool. Thanks for being here today, and thank you to all who attended, and thank you, Louis, and the rest of us who had to leave because it's really late or really early, I think. But yeah. All right.
Well, could I ask a question?
Thank you so much, Danny.
Yeah, Louis.
Oh yeah, sorry. I just wanted to ask Danny if, personally prefer to write JavaScript or TypeScript. I do believe, I'm not sure, but I guess people like that control of types, so that you have less when you're writing in JavaScript. But I don't know, for your self-preference, do you think TypeScript is a good addition to the languages we have?
Yes, I think TypeScript is great. I love it. I write most of what I can in TypeScript. I'm comfortable writing JavaScript, but TypeScript, the editor helps me out so much more. Come back to code. So I write enough code that I come back to it 6 months later, and it's like somebody else wrote it. I recognize my style, but I don't remember anything I wrote. And so in something short like what we wrote today, it really didn't provide a whole lot of value. And so JavaScript was fine. But imagine I wrote a project that was 100 lines long or 100 files big, or commands, and maybe it used some other API or some other project in some fancy way and built some complex objects. I would come back and I would types a lot quicker than if I were to read JavaScript. So in my mind, TypeScript allows me to communicate with my team members effectively. It allows me to communicate with myself effectively because I forget things all the time. And projects that I work on now start to live a lot longer. When I was in college and doing a lot of training, I didn't last long, and I would write a project for a semester. And so really JavaScript was fine then. But now that I'm working with 30 people, and sometimes I don't even know some of the people on my team very well. I don't know what they're writing, but I can look at their code, the types, and I can say, this is where the value goes, and this is what the contract is that I need to follow, so I can use what they've generated and what they've built effectively. I find TypeScript very helpful for that.
Nice.
Yeah, no, just the last question, I guess. I do think there's at least I've seen in the writing of your code. This is just more about the organization of your code. So there's an example you've given where I think a really neat one where you first wrote them without functions, added functions to them, then all in all moved the function to another file. So I don't know what's the best practice. I do know people encourage functional programming, but so the first question is best practice in how you organize your code as a web developer or when you're doing your projects. And then the second question is, I think as Node and as JavaScript grows, I think then we have packages that make you write less code. Do you think there's any benefit in like learning the old naive style, like just knowing, okay, Express does this, but behind what Express does, this is what goes on? Is there any value? Or is it just written so well that we'll never get a bug that needs us to know exactly what's going on behind everything?
Yeah, those are really great questions. For the first, my philosophy is that longer than 100 lines of code. Longer than 100 lines of code, it doesn't fit on my monitor well. It doesn't fit on my big monitor that well. And I start forgetting things. And then I can't remember every once. And so I start pulling things out into separate files. And I start looking for things that are separate. Like sleep is a utility function that I might want to use in other places. So I'll pull that out. And maybe I keep it all together in multiple files. Same thing. Once I get to 5, 10 files, I start to think, that's a lot of files. Do I really need all those files? Could I pull those out into a separate thing? And so really, as I've developed, I've learned what my limits are and what limits of other people are. And so as you write code and as you come back to it, especially, you'll start to learn, I don't like this. I don't like what I did here. And you can start to teach yourself like, oh, if I do these kind of breaks, and if I keep a function down to 25 lines, or I'm happier with it. Easier to read, because what as you are learning to code is you write, but what will happen later is you will start reading a lot of code, and that's a very different thing to learn, is how to read code and then write code for reading later. That's the difference between just coding, programming, and software engineering. In software engineering, you're actually engineering software to be read by a human and to tell a computer what to do quickly. And so that leads into question number 2, which is, should you learn the underlying basics? And I think, yes, there's a lot of value, because knowing that allows you to look at a say, they didn't do that well. For instance, there was, whenever I found the memory leak in our application, I was looking through code and I was reading it and I was looking and saying, wow, this package is really complex, and they have really long functions, and they go through functions, to get back over here. And there was a lot of things that didn't feel, that were unsettling to me. And that was to tell me like, hey, I'm not reading code that has been engineered quite as well as I think it could be. And then I found the line that kind of like held on to too much, and it wasn't obvious at first, but it became, as I like started to recognize like, oh, hey, this is what's happening under the hood. So you can use these tools, and they help you build great things. But as you start to maintain them, having a basics of what's actually going under the hood, even if you don't have to use that much, remember, well, I think I remember like some keyword, I could go and Google it. Maybe that will help you like later. So yes, I always encourage reading and learning some of the low level stuff, and try and build some library yourself. Like this, and imported it from npm, but look, it's 5 lines of code. It's really easy to implement ourselves. And now I could tweak this. I could keep this, share it. I can't tell you how many times I've written the sleep function, like probably 100, and just put it in different files, because it's so much easier to write here than to actually try and find a library to use that maybe doesn't do it as well, or maybe just I just didn't need. And maybe we have like, company policy prevent us from using those things. There's a lot of complications that sometimes show up. But anyway, yes, use the tools, use them, and definitely take advantage of them. But don't be afraid to learn the basics, because then you'll have a better grasp of when to reach for a great tool, what a great tool looks like, and what to write it yourself.
Awesome. All right, I think that's all from us. Thank you again, Danny.
Yes.
Yeah, thank you so much, Danny, for attending, for showing up to speak at the event. I know the turnout doesn't look that great, but 2 reasons. First of all, it's really late here because our class is kind of scattered. So some of us are in India, others are in San Francisco, and so a lot of people actually reached out to me before the session, which is why we're recording this session so that they can watch the recording later on. And yeah, the rest of them just have to go sleep. But yeah, thank you again for your time. This was a very great and insightful session, and I hope you enjoy the rest of your day.
I did, and you four was totally worth it. So, or you three, glad that y'all were able to make it. And if you have any more questions or want to know more, email me.
Yeah, I look forward to collaborating more with you.
Yes.
All right.
Bye. Thank you.